let me do this homework problem. 3 students take courses at 2 different colleges, WU and FCC. WU charges $200 per credit hour, which is equivalent to our unit, and FCC charges $150 per credit hour. The number of credits taken by each student at each college is given in this following table. So there's student 1, the number of hours at WU and the number of hours at FCC, and remember 2 different prices. So he pays certain prices for the first school, certain price for the second school. Same thing with the second student, and same thing with the third student. And the question is, do you use matrix multiplication to find the total tuition paid by each student? Let's do it manually. Student 1 takes 11 units at WU, and that's $200. And 7 units at FCC, and that's $150. So you can just multiply and add. So in a way, you can sort of cheat and finish this homework problem without using matrices by just taking 11 times 200 plus 7 times 150, which is 2200 plus 1050 equals 2250. And then you do that for student 2 and student 3. So yeah, you could cheat and not use matrices, but I'll show you what a matrix has to do with this. Because if you go on and take more classes in the STEM field or in the business field, or especially in economics, this is how economists model spending or production in an entire economy. They can't do arithmetic all the time. You have to model it using a matrix. But this main idea is still the same. You want this, if you think of this as a matrix, right? So I want to take this matrix here. That's 11, 7, 4, 6, 3, 3. That's 11. Let me fix that. And I want to multiply it by some matrix because the question gives me that hint. I want to multiply it by some matrix. And the answer should be this stuff, right? I want these to be the answer. So 11 times 200 plus 7 times 150. Down here would be 4 times 200 plus 6 times 150. And down here will be 3 times 200 plus 3 times 150. All right, so the question is, how do I fill in that second matrix? Once I've written out this way, you sort of suspect the number 200 and the number 150 should go in there somewhere. But let's go slow. This is a 3 by 2 matrix. And the answer, all of this is going to be a single number. Okay, it looks like a big calculation, but it's just a single number. So the answer will be one of the matrix with a single number and a single number and a single number in a column like that. Okay, the answer will be a column of 3 numbers like that. It will actually be like this, right? A column of 3 numbers. So in other words, 3 rows, 1 column. This is 3 by 1. So in order to multiply correctly, remember for matrix multiplication, in order to multiply correctly, the inside dimensions have to be the same. So this has to be 2. And it has to be 2 by, like when you multiply M by N matrix times a P by Q matrix, and what happens is, no, this has to be an N. It can only be multiplied by an N by Q matrix, right? These two have to be the same, and the final result will ignore the common here and goes M by Q. The first number of rows times the last number of column, and the inside row and column got to be the same number. Okay, that's the only way for matrix multiplication to be defined. So you have to be some sort of 2 by 1 matrix. Okay, so that we get an answer that's 3 by 1. So in other words, we know that our matrix will look like this. You have to be a 2 by 1 matrix. Okay, 3 by 2 multiplied by a 2 by 1 to result in a 3 by 1 matrix. All right, now how do we multiply matrix? When we multiply matrix, or we multiply 2 matrices, we're at the row I, and we're at column J, then what we do is sort of like match the terms. Okay, that's why the number of column of one has to be the same as number of rows of the other, so that when I turn them around, they match. Okay, the numbers match. I match the numbers and then I add them, right? That's the technique of multiplying. So that means I need to multiply 11 times this and 7 times that, and then I add. Oh, look, 11 times this and 7 times that, and I add. So that tells me that I ought to put the number 200 here and the number 150 there. $200, $150. Then yeah, look, that gets me what I need. So let me change colors so we can follow. If I change the 200 and 150 into red, then you can see that you want the 11 times 200 plus 7 times 150, which is what we want: 11 units of the expensive school and 7 units of the less expensive school. And once you get to the second row, then it's this 46 times the 200, 150. So that's this 200 times 150. And by the time you get to the third row, same thing. You're going to take the 3 times 200 and 3 times 150. And in fact, if I change color again, I change the 7, 6, and 3 into green, and you can see that it corresponds. The 7 and the 150 go together. 11 and the 200 go together. When you multiply matrix, you take a row times a column by sort of like matching the entries. Right? So that's how you realize that this can be done with matrices. Of course, you can also, like I said, you can also do it without matrices, but that's not the point. Okay, the point is not to make you add two numbers. The point is to see if you can figure out how matrices can be used to model basically an economy. So in this entire economy of students taking classes at 2 schools, what's the total production or the total costs or the total spending within this economy? Well, you take the matrix of this, what it is that the economy is spending money on, you multiply by the matrix that represent the prices of those goods, and the product of the goods matrix times the price matrix is the cost matrix. This is the cost spent by these students. Okay, and then you can work out the arithmetic. Okay, hope that helps. Bye.